What's poppin', dogs? Mr. Allen here, solving for some missing sides and angles in a non-right triangle, right? We don't have right angles here, so we got to do it a little differently with some non-right triangle tricks. So in triangle ABC, we've got the measure of angle A is equal to 123 degrees. I'll go ahead and label that. I got AB is 14 feet, so that's this segment right here, this side of the triangle. And then BC is 29 feet, which is this guy right here. Okay, and I got to solve for all the missing sides and angles. Sometimes they say, solve the triangle, and that just means solve for the missing sides and angles. Well, it helps to identify what kind of situation we have going on here. If I'm going to use law of sines, law of cosines, I don't know. Right? Well, I do have an angle across from a known side, which means I can use law of sines. But I'm also noticing here that this is an angle, a side, and a side. Not angle, side, angle, because if it was angle, side, angle, it'd be this angle right here. But because it's this angle, it's an angle side situation. Now I usually write this abbreviated, but I'll go ahead and spell this one out. Otherwise that'd be quite hilarious, yes, if I just abbreviated angle side. Well, anyways, there's some special things that happen here with an angle side situation that you got to double check and make sure you don't screw up. Otherwise you might make yourself look like an angle side, you know what I mean? All right. Well, what I'm talking about here is the ambiguous case, the possibility of there being 0, 1, or 2 triangles when given the angle side information, right? There's the potential for another triangle to exist or just no triangle at all to exist with these sides. So we are about to find out, okay? The nice thing about if it's no triangle is that the math will just be like, error, no. It's the 1 and 2 triangles that's kind of tricky. So let's first just set up law of sines. So let's set up our super proportion here, right? So enough yapping. Let's get to mathing. So I'm going to take the one that I know information about to put in the middle here. The reason why I do that is so that I have a completed ratio in the middle here so that when I do cross multiply, right, I can just ignore this one. I got these 2 to work with. I can just ignore this one. Now I got these 2 to work with, right? That's what I like to do. You don't have to do that. It's up to you. I'm solving it, so I'm doing it that way. The other thing I know is, let's see here. We want angle C, and I know the side across from that. So we'll just say sine of C, and then 14. And then I also don't know B or even little b right here. So sine of B over B. So we notate angles and vertices of that triangle with uppercase letters, big letters, and then we use lowercase or little letters for our side lengths that are across from that angle. So across from big B is little b, all right? So uppercase and lowercase does matter. I always stress that even if we're not into this yet, just because eventually it does become a thing in more advanced mathematics, like we're doing right now. So now we can cross multiply and solve, and I believe the only thing I can really do here is angle C, okay? Because I know nothing about these two. I got to solve for one where I only have one missing piece of information in that guy. So let's cross multiply and figure that out. So we'll deal with this one first. So I've got, let's see here, 29 sine of C equals 14 sine of 123. Then I'll divide by 29. Yep, 29 and 29. And I'm left with sine of C equals this whole mess, which is unfortunate because I'm like, well, how do I get C by itself, right? Well, there is what's called inverse trig, which undoes that trig function. So if I take the sine inverse on both sides, so the sine inverse of all that stuff, that will give me the measure of my angle because that's going to be gone, and I'll be left with just C. So I'll have C equals, let's type it in. So to do that, I'm going to hit, let's see here. First will be second sine. Oops. Got to make sure I'm on my calculator here. 1 sec. Boom. Okay. So I'm going to actually hit mode first. Make sure I'm in degree mode. Okay. I always check that first, right? Unless if I'm going on this, I'm good. I'm not going to check it every problem. It's not going to magically go back. But sometimes we go from units where we're dealing with radians and then all of a sudden degrees, and you got to, flip-flop a lot. That's the tough thing about pre-calc. Okay. So I'm in degrees. Now I'm going to hit second sine for sine inverse, and then we'll do alpha x to get a fraction, or alpha y equals to get a fraction. And I'm going to type that whole mess in. We got 14 sine of 123, close your parentheses, down here, 29, arrow out, close them, hit enter, and I get 23.88. That's the measure of the angle, 23.883, so 88 degrees. There we go, 23.88 degrees. Okay, so now what's going to happen is For the potential for another triangle to exist, okay, for the potential for another triangle to exist, we're going to take the supplement of this angle. So 180 minus, and you can either use the one that's in there or you can use this rounded value. I know this is you only round once, but because I'm saying this is the angle of the triangle we're working with, that's what I'm working with now. Okay, like that is my angle. We're not continuing to calculate in an application setting where we're getting different heights and different angles and those errors would compound. This is it for the triangle. So what I'm going to do is 180 minus 23.88. Hit enter. I got 156.12. So that's the other potential angle that we would have. Now that angle plus the 123 that already exists, that exceeds 180 degrees. So there'd be no more room for angle B to join the party. We've exceeded 180 degrees in this triangle. So in this case, only one angle exists, okay? So the reason why we do the supplement, I'm going to draw up a little triangle right here to show you guys what I mean. It's hard to see in this one, but the reason why we do the supplement is if I were to find this angle right here is my 23.88. Another angle, or another triangle to exist would require this guy to swing in right here. And now this 23.88 is also this angle, and the supplement of that is the other angle that could exist. It's a little weird when you're not drawing it, when it's like it's not going to exist in this triangle, so it's hard to visualize it here. I have another video on where two triangles do exist, and I think it's easier than to see why we do the whole like 180 minus that and then add them together to see if it still works in a triangle, okay? But the quick check is I get my angle, 180 minus that angle, whatever that is, plus the existing angle. If it exceeds 180, can't have a second triangle. If it didn't exceed 180, we would have a second triangle existing. All right, so let's finish this one out here. We're going to solve for the rest of our angles. I got 123, I got 23.88. So 123 plus 23.88, and I'm going to do 180 minus that. And again, I know I'm using the rounded value right now, which seems weird, but here's the thing, is this is going to be 33.12 degrees. I want all three of these angles to add up to 180 degrees. And if I were to use the non-rounded or super decimal answer that's in my calculator, there is a chance for these to be like 100th off of 180. You'd end up with like 179.99 or 180.01, and you could be marked off for something like that because all the angles must add to 180. Cool? So since I'm saying this angle is 33.12 degrees, I'm going to use that to solve for B so that it works with this triangle. I know I'm being probably pretty nitpicky on this, but there's reason to it. You know, I got a little reason behind it. So anywho, all right, let's do, I guess we'll go to blue now. We'll solve this guy right here. So we still have our sine of 123, and I'll write the whole proportion here. Sine 123 over 29 equals sine of now 33.12 over B. Will cross multiply. B sine of 123 equals 29 sine of 33.12 divide sine of 123. And luckily, that's what I'm just going to type in, right? That's all I'm typing in to my calculator. That's all I'm typing in because that's going to be B. That's going to cancel out, and I'm left with just B. So alpha x, we get 29 sine of 33.12, close my parentheses, arrow down, sine of 123, and I get 18 point, what do we want to write this in? I guess we'll do right here. B, 18.893, 18.89 feet. Okay, so we've got all three of our angles. We've got our side that was missing. So, yep, we're good. So we needed two angles, the two pink ones there, and the blue one there, B. We got 18.89 feet. One tick mark means feet, once again. And that's it, guys. So one triangle in the angle side situation. You got to check for those. Hopefully that makes sense there. But also check out the one where I solve with two triangles because I feel like it does make sense, the actual drawing of it. And there's even, I have a little video of like showing the hinge theorem as to why it swings in and there's a potential for two triangles to exist with angle side. It's pretty dope. Super dope. You guys are dope. Have a great day.